Welcome to another data mining video. Today, Brenda, Ariadna, Fatima, and myself are going to introduce a new type of cluster algorithm. This is called the fuzzy C-means algorithm. First of all, let us explain you how this algorithm works by showing you its flowchart. Once again, and just like in the case of the chameleon that we showed you the last class, do not worry about this image resolution because it is going to be shown and further explained in the document that we just sent you. The masterminds behind this algorithm could be considered two people. The fuzzy C-means algorithm, or FCM to short it, was developed by Dunn in 1973 and improved by Bezdek in 1981. The problem of classifying outliers gave rise to a non-hard algorithm flexible enough to effectively deal with data points. About its characteristics, we have that the fuzzy C-means is one of the most widespread algorithms for fuzzy partition clustering. Also, it works by assigning membership to each data point into n clusters, with every data point that belongs to other clusters with a certain degree. Its objective is to minimize the weighted sum of Euclidean distances between the objects and the means of corresponding clusters. And also, it is used in many areas that go from social science to engineering through basic science. It is commonly used in pattern recognition, image imitation, image clustering, big data, etc. Type of data used. This is a bit tricky. According to Day1, Sharman, and Akasu, traditional fuzzy C-mean type algorithm is limited to numerical data. However, in their paper entitled Fuzzy Clustering Technique for Numerical and Categorical Dataset, they presented a modified description of cluster center to overcome the numerical data only limitation of fuzzy C-mean algorithm. Their proposal, called Fuzzy K-models algorithm, is able to work with categorical data as well. Its categorization. First of all, let us not forget that clustering is divided into two types: hard clustering, where each data point either belongs to a cluster completely or not, and soft clustering, also referred to as fuzzy clustering, where instead of putting each data point into a separate cluster, a probability of that point to be in other cluster is assigned. In other words, it allows a data point to be part of more than one cluster. As you might imagine, fuzzy C-mean algorithm belongs to the soft clustering type. Let's talk now about its advantages and disadvantages. First of all, it gives best result for overlap dataset and comparatively better than the K-means algorithm. Unlike the K-means, where data points must exclusively belong to one cluster center, here data points is assigned membership to each cluster center, as a result of which data point may belong to more than one cluster center. Also, it has a low time complexity, and it always converges. The disadvantages are: first, you need an a priori specification of the number of clusters. Also, the Euclidean distance measures can unequally weigh underlying factors. It is sensitive to outliers, and it is sensitive to centroid initialization, meaning different initializations may lead to different results. With the aim of providing you with a better idea on how this algorithm works and how it can be implemented, now my partner Ariadna will show you an example using Python.
First step of this algorithm, which is data generation, we will define three cluster centers, which are the main values for the clusters. Next, we will define three cluster sigmas in X and Y respectively. After, we will generate the test data by using the random function by each X point and each Y point. Next, we will use the Gaussian distribution using U and sigma as the characteristic distribution by setting U as the mean and sigma as the standard deviation. Then we will visualize the test data by testing data of 200 points for three clusters. Then, in order to know how many clusters we should expect, we need to cluster our data several times between 2 and 9 clusters. Then, we use the separation coefficient for this algorithm, which is defined on a range from 0 to 1, with 1 being the best. This is a metric which tells us how clearly our data is described by a certain model. Next, we will cluster our set of data, which we know has 3 clusters several times, with between 2 and 9 clusters. We will then show the results of the clustering and plot the fuzzy partition coefficient. The partition coefficient is maximized and our data is described best. After that, we classify the new data. In order to cluster the data, the next step is often fitting new points into an existing model. This is known as prediction. It requires both an existing model and new data to be classified. In order to build the model with 3 cluster centers as we got into plot, we rebuild the 3 cluster model for use in prediction by generating new uniform data and predict which cluster to which each new data point belongs. In order to do so, we will use the cluster centers with a number of 3 and Setter ordering. Finally, in the stage of prediction, we generate the sample data in a range of 0 to 10 in X and Y. Then we predict the new cluster membership with setMeansPredict function. In this part, we define the parameters of new data center to an error of 0.005 and number of maximum iteration of 1000. Then we plot the results of the cluster membership and we make 3 clusters.
Our conclusion on this algorithm is that it is a quite good alternative when talking about the need for clusters. It has a good performance computationally speaking, and it always converges. It is a quite better idea than the k-means algorithm. Nonetheless, and just like we just heard on the disadvantages section, it has some weak points that can easily guide you to a not accurate answer. After all the research we have done, we consider this algorithm must be used by people with plenty of experience because there's a lot of things to take into consideration in the preprocessing section for a good output.